All right, so if I can get my screen up here. So now we're going to talk about the other main type of volume problem volume of a solid with a known cross-section. It's too bad we're not back in good old C111, of course, because I think I still have all those pipe cleaner things that you guys made earlier in the year. So hopefully you can visualize those. So for this, I'm going with the same region here, bounded by x squared and square root of x, so this region. And this time we're going to build the shape. We're not going to revolve it. We're going to build the shape up out of the paper on top of this region. So this region is the base. And the way to describe this is what the cross sections are, and they'll tell you which axis the cross sections are perpendicular to. And so in this case, they come right out and tell you cross sections are perpendicular to the x-axis. And so I set up a dx rectangle that is perpendicular to that x-axis. And then they're going to tell you what the shape of that cross-section is. And so we'll do a couple here. So we've got squares. And so the idea is we've got that dx rectangle. And then I was doing so well on my pictures. So we've got these squares, and that little thickness is dx. And so we need to find the volume of this little box shape. How long is this side? Well, that's this side that's sitting on the base. And so this is just that x squared minus square root of x, which is the top and minus the bottom. And so the volume of this box will be length times height times that thickness. And so it's just x squared minus square root of x. And that's the side length. We square that. We multiply by the thickness. And we add it up from 0 to 1 because these nicely intersect at 1, 1. And my x's go from 0 to 1. This one would definitely be a pain to do by hand, doable, but definitely a pain. And so you would just do this on your calculator, watch your parentheses, you're squaring that big thing. If the cross section is a semicircle, we again have this length, this x squared minus the square root of x. And then we've got that thickness. Again, my drawing's not perfect here, but you've got that little thickness. So we need to find the area of the semicircle and then multiply by the dx. And area of a semicircle is 1/2 pi times the radius squared. And you just have to be careful here. In this case, this length is not the radius, it's the diameter. And so we find that length. And again, we divide by 2. And so radius squared 1/2 pi because it's only a semicircle. And then, of course, you add this up from 0 to 1 once again. And again, you would do that integral on your calculator. So volume of solids of a known cross-section different than solids of revolution.